Welcome to this installation and a complete walkthrough for DFM, Data Flow Manager, on Azure Kubernetes Services, that is AKS. So, what is Data Flow Manager? What does it actually do? And how it improves your daily work? So, Data Flow Manager is a platform designed to streamline, centralize, and govern the complete lifecycle of Apache NiFi data flow. It has its own capabilities. It provides a unified interface that replaces the need for direct interaction with the NiFi UI. It allows users to deploy, configure, schedule, and monitor data pipelines across multiple clusters with ease and precision. It reduces your operation costs up to 70% with just plug and play, has zero data risk, and also doesn't impact your current setup. Now, why AKS? What are the benefits of having AKS? So, AKS provides automatic scaling for application workloads. It ensures high availability, self-healing of application pods, and reduces operational effort with a fully managed control plane. It integrates seamlessly with Azure services like Key Vault, Monitor, and Storage. It provides strong security with Azure AD and RBAC. It not only optimizes the cost through auto-scaling in spot nodes, but also enables easy, consistent deployment using Helm. We will walk through the entire deployment process by following the document, which provides a comprehensive guide for preparing and deploying the DFM on AKS using Helm. It outlines the required tools, Kubernetes resources, secrets, certificate management setup, and the necessary updates to the Helm chart configuration. Following these steps ensures a consistent and reliable deployment process for the DFM application. So now, before deploying DFM, ensure that your machine or a server used to interact with the Azure Kubernetes cluster has the required Kubernetes command line tools installed. So you must first set up an AKS cluster by following the link to create the cluster. Next, you have to install Azure CLI by using Azure CLI installation link provided in the guide. So after installing, you can check its version with command az version. So as you can see, I have Azure CLI installed in my system already, which is having a version 2.80.0. Now, configure Azure access details as your env variables, which are listed below: tenant ID, client secret, subscription ID, resource group, and the cluster name. The specific details are already mentioned in the guide, which you can follow, and note all these details after having AKS set up on your system or a server. Now, you have to run the following commands in your terminal to configure all required Azure environment variables. Export tenant ID equals to tenant ID. So I'm already having some of the details which are handy, and I can just copy them, paste them onto the terminal, and run the command. So now, as you can see, I have set tenant ID, client secret, subscription ID, resource group, and cluster name as an environment variable. Now, if I want to take a look if my tenant ID is set or not, I can just run through with the command echo -e and follows the same as mentioned in the guide. So just copy it, paste it, and here you go. So as you can see, the tenant ID I have set is same, which has been provided as an environment variable. Now, you can log into Azure cluster using az command and obtain the Kubernetes cluster configuration. Just copy this command, go to the terminal and try to log in. So as you can see, now with the client ID, secret and tenant ID, I am now able to access my service principal. So the Azure CLI operations must be authenticated before you can interact with Azure resources. That's why this whole login to Azure account is needed. Moving forward, you have to get the Azure Kubernetes cluster config. Copy the command as mentioned in the guide and run it. So as you can see, DFM AKS demo admin has been set up as a current context in kubeconfig file. So this command downloads the kubeconfig for the AKS cluster. It either merges or overwrites your local kubeconfig file with credentials and cluster details. After running this, tools like 𝐒𝐞𝐳 can talk to your AKS cluster. So far we have been authenticated with Azure using the service principal and downloaded the Azure kubeconfig. This allows 𝐒𝐞𝐳 to communicate with the cluster. So, if you plan to deploy DFM on a public IP address, ensure you have a static public IP reserved and available. This IP address must be specified in the Helm chart configuration to correctly generate and bind the necessary TLS certificates for secure communication. Make sure to note down this IP address as it will be required in later step. Before setting up an IP address, you must need to get the node resource group name. Just copy the command from the guide and run it. This command retrieves the node resource group of your AKS cluster and stores it in the shell variable node_rg. AKS stores and manages all load balancer and public IP resources in the node resource group. The public IP must be created there for the cluster to use it. Now, next we will be getting the cluster location. So we need this location as a cluster's location or a region to create new resources, like a public IP in the same region to ensure compatibility and avoid cross-origin deployment errors. If you now want to take a look what your node RG and location is, you just need to copy the command from the guide and run it in the terminal. So as you can see, creating test IP in MC 𝐬𝐷 testing DKS AKS demo West US 3. So this is my node RG. I just have to copy it and store it somewhere in my notepad so that I can reuse it further in later steps. And as you can see, $location was one of the variables which has been set to locate the location. So location has been set as West US 3. So these two variables has now been set, and now to set up a public IP address, you just need to run the command by copying from the document. So after a little bit of time, you will get the IP address here, which you can copy and paste it somewhere in your notepad so that you can reuse it later. After setting up and noting the IP address from a system, you must have to install kubectl and Helm on your server. Kubectl is primary command line tool for managing Kubernetes clusters, and Helm acts as Kubernetes package manager and is essential for deploying DFM. To install both, you need to run these commands, where first one is to run the kubectl and second one is to run the installation for Helm. These commands will download the latest stable versions of your kubectl in Helm and sets the executable permission so it can be run from anywhere. Moving ahead, we have to set up the cert manager utility configuration. Now, just copy this command, paste in the terminal, and here you go. So JetStack has been added to your repository. The message would appear. So this cert manager must be installed on the cluster to handle all TLS certificate creation and management tasks. It automates issuing, renewing, and maintaining certificates required for secure access of the DFM application. Now, you have to run the other command to upgrade the JetStack cert manager. So it will take 3 to 4 seconds and will install the cert manager utility configuration on your server. So after having a cert manager installed on your system, we would be moving to the next step, which is prepare Kubernetes components for DFM deployment. So here, DFM requires two primary Kubernetes secrets for operation, which are application secrets and licensing information. Before that, we have to create a namespace for DFM deployment, which ensures and lets you group resources logically. For example, if you are having separate dev, staging, and prod workloads, so you can group resources by team, for example, team A or team B. So now, for creating a namespace, just copy the command from the document and run it in the terminal. So as you can see, the namespace DFM has been created. Now moving ahead, I would be setting up Docker registry secret. So if the DFM Docker images are stored in the private registry, create the following secret so Kubernetes can pull the required images, where this command requires your authentication details as well, where Docker username and the Docker password to provide an access with credentials. So you can replace your username and the password here in the command. I have it already handy. Running it through the terminal will create a Docker registry pull secret in Kubernetes, which allows the cluster to authenticate and pull images from Docker Hub. So here, various flags are having various specification which you can follow through the guide. Now moving ahead, we have to set up the DFM app secrets. These secrets store database credentials, security tokens, and encryption keys needed by DFM. You just need to copy this command, replace the DB user, DB password, DB name, JWT secret, encryption key, and DB client, which is Postgres itself, according to your choice. Here in the guide, for each flag, it is mentioned what details each flag will carry. So I'm just using the default ones, running it through. So as you can see, DFM app secrets has been created now. So you can run the same in your system. Now following ahead, as I mentioned earlier, that two primary Kubernetes secrets for operation are application secrets and licensing information. So now to set up licensing information, you need to run the command as mentioned, which will create a Kubernetes secret named DFM license that stores the DFM license file required by the application. So you just need to copy the command from here, and as you can see, from file is having a path to DFM license. So this DFM license will be provided to you via email or one password or any other secure channel so that you can put it somewhere in your system and can use a path for this particular command. So I'm already having DFM license handy with me. I'm just running the same command in the terminal. Now you can see secret DFM license has been created. Now before proceeding with the DFM installation, you must first download the DFM Helm package, a zip file that has been provided via one password or any email. And after downloading the zip, you must have to install the unzip on your system. If you don't have unzip already installed in your system, you can follow the command sudo apt-get install unzip-5. So it basically installed the unzip package onto my server. Moving ahead, I have to unzip the DFM helm.zip, which has been downloaded via one password or any secure channel. So now here, if you type ls, you can see I'm having DFM license and DFM helm.zip already downloaded. So now by using unzip command, I can just unzip the DFM help.zip. It has various details available which will provide an ease to run through the DFM application easily. Now you have to just look at the directories. As you can see, previously I was having the zip and the license text file. Now I have unzipped the archive. So after unzipping DFM Helm package, now we configure the DFM Helm chart. We will update the image details, service exposure, environment variables, ingress settings, and certificate configuration via values.yaml. So to open a values.yaml file, you must need to enter into the DFM Helm directory, which once you look at the directories, you will get DFM Helm as a directory listed. So type in cd dfm-helm, the name of the directory, and enter. Now you are inside DFM Helm directory. So we have to update the chart values.yaml file according to the following instructions mentioned in the guide here. So type in vi values.yaml to open up the YAML file. Now first configure the repository pull secret created in the previous step, which I have used as DFM Docker key. Then in next action, you can configure the service settings as needed. Set the service type as load balancer when you are exposing it via a public IP and specify that IP under load balancer IP field. So the IP which we have created earlier will be used here, as I have mentioned to make a note of the public IP which you are setting up and will be used in the Helm chart configuration. So I just replace the IP address here, and here you can set the service type in cluster IP when you intend to expose it through a domain name mapped internally. Moving ahead, you have to update the core application environment variables, where base URL, SSL enabled, and OpenAI key are some variables which needs to be updated in values.yaml. So here in public IP under environment, I'll again set my IP to provide an access to the UI. Next update would be for the ingress configuration. It enable and configure the section only when you are exposing DFM through a domain name, which has various flags, and each and every flag specifies a particular individual action. Next, you have to update the cert manager section, where you can enable self-signed certificates only when accessing DFM through an IP address. You need to add the IP address to your cert manager details as well. Moving ahead, Scrolling down. Here in IP address, I will update IP address which I have noted earlier. You can also enable Let's Encrypt when you are exposing DFM through a domain name for allowing Cert Manager to issue publicly trusted certificates. Moving ahead, we are now done with our values.yaml configuration setup, and you just need to follow this particular guide to set up as much as configuration as per your need. Now I will come out of this file and will follow the document ahead. Now finally, DFM Helm chart is now available for deployment to target the server environment. What you need is just run this command in your terminal where it will install the DFM using Helm. As you can see, my DFM was not existing in the server, so it has installed it with namespace DFM, and as you can see, the status is deployed and the name is DFM. It also has various details available for monitoring purpose. Now you can check if the DFM has been deployed to the cluster correctly using the following command: kubectl get all -n DFM. It will list out all the pods running, the services, and the replica sets which has been set. So as you have seen in values.yaml, we have set replica count as 1. So as you can see, we have desired value as 1. So I'm having single pod running for DFM now. Now access the same application on browser. We are now finally done with each and every configuration for setting up DFM on AKS. After having a successful installation of DFM on AKS, you can now access and verify the deployed DFM through your browser. Open up a tab, type in the IP address, the public IP which you have set already in the steps, and as I have used self-signed certificate, so it is asking me to proceed with a private connection. So now as you can see, my DFM application is ready and being available on the IP address.